Welcome back to our Chem 152 video series. In this video, we'll be discussing Le Chatelier's principle. In this problem, we have the reaction 2NO2 gas yields N2O4 gas. We are also given an enthalpy change of negative 57 kilojoules per mole. The question asks, which way does this reaction shift in the following situations? First, we'll talk about adding extra NO2. First, we'll write down the reaction and think about whether NO2 is on the left or the right. When we locate NO2 in the system, we see that NO2 is on the left. Le Chatelier's principle first says that if you add something to the system, you'll shift away from whatever you added. Therefore, if we add extra NO2, we're going to shift away from NO2. Since NO2 is on the left, we will shift right. This also means that in adding extra NO2, we'll be using up the NO2 that we just added and make more product. That's N2O4. Now, what if we removed NO2 instead? If you remove something from an equilibrium reaction, we shift toward what we removed. Now, NO2 is still on the left. But because now we're removing the NO2 for part B, that means we shift toward what we removed, therefore we shift to the left. This also means that we are replacing the NO2 that we removed. Anytime we are reacting left, we'll be replacing what's on the left. To show that, we'll also replace this arrow that is currently a single arrow with a double arrow, showing that it is possible for us to react backwards. If we remove that NO2, we will replace the NO2 that we just removed and use up N2O4 to do that. The takeaway here is that we shift away from what we add and shift toward what we remove. Now imagine if we removed the N2O4. We locate that in the system and we notice that N2O4 is on the right. We're always going to shift toward what we remove. Therefore, in this case, we will shift toward the right. If we do shift toward the right, that means we'll be using up whatever's on the left and replacing the stuff on the right that we removed. Therefore, we can say that we will shift to the right, we will regain the N2O4, and use up the NO2. Now let's go to part D and think about adding heat. Adding heat is a case where we have to look at the enthalpy change. We need to think about whether the enthalpy makes this reaction endothermic or exothermic. Our enthalpy change is negative 57 kilojoules per mole. If our enthalpy is negative, that means the reaction is exothermic. If the reaction is exothermic, that means it produces heat. If the enthalpy was positive, it would be the opposite. The reaction would be endothermic and would require heat as a reactant. In this case, our enthalpy is negative. The reaction will produce heat, and we will write that heat is a product of this reaction. To show that, we write the word heat on the right side of the reaction. Now, let's think about what happens if we add heat. If we add heat, we're adding something that's on the right. And we always shift away from things that we add. What that means is, since the heat's on the right, we shift away from the right, and so adding heat would shift us left. So in this case, adding heat would shift us left. Of course, this all depends on what side the heat is on. So it's important to check your enthalpy and make sure we recognize whether the reaction is endo or exothermic. When you have a reaction that either produces or uses up gas, we have to think about the effects of increasing or decreasing the pressure on the system. First, in order to look at pressure, let's look at the moles of gas that are in the system. Now, when we look at this equation, we notice that we have two NO2s on the left and one N2O4 on the right. Both the NO2 and the N2O4 are gases, so we have 2 moles of gas on the left and 1 mole of gas on the right. Now we are going to look at the side that has more moles of gas because that's the side that has more pressure. We can actually write the word pressure on the side that has more gas. Now let's imagine if we increased the pressure on the system. So if we are adding pressure to the system, we are adding something on the left. And Le Chatelier's principle says that if we add something, we shift away from it. So shifting away from the left would lead us to shift right. Now, increasing the volume of the system sounds like something a little unexpected, but we have to think that increasing the volume of the system would lower the pressure. So if we lower the pressure, we have removed something that's on the left. And remember that anytime we remove something, we shift toward what we removed according to Le Chatelier's principle. Therefore, if we remove pressure, Le Chatelier's principle says shift toward pressure. Since pressure is on the left, we would shift left. To show that that's possible in our reaction, it would be correct to replace the single arrow with a double arrow. And so now we've covered a number of cases where we deal with Le Chatelier's principle and figuring out whether to shift left or right. Thank you for watching, and we'll see you again soon.